Okay, I want to go back to our sodium atom. And we know that sodium is in the third row, so how many energy levels does it have? 3. 3. Okay, so sodium has 3 energy levels. And specifically, I want to know how much energy does the electron in that third energy level hold? How much energy does that electron in the third energy level hold? So the N just represents what energy level the electron is at. So if this electron that I want to know is in the third energy level, I'm just going to say my N is equal to 3. Let's say I don't want to know anything, though, about the one that's here. What if I want to know how much energy the electron and one of the electrons holds in the second energy level? What would my N equal to then? My N would be equal to 2 because this electron is in the second energy level. What if I wanted to know how much energy the electron has in the first energy level? So my electron's right here. How much energy does that electron have? What would my N be equal to? Well, in this case, my N would be equal to 1. And why is that? Because the electron is in the first energy level. So your N is really just a representation of whatever energy level that electron is in, or whatever energy level that is in. Okay, so N is just your energy level. So that's what they mean there by saying N equals 1, 2, or 3. It's just what energy level is that electron at. Okay. Okay, now, sorry guys. Okay, let's keep going. I am moving on to slide number 7. On slide number 7, it says that energy in atoms, it says energy in atoms is quantized. That should say energy in atoms are quantized. And that just means, quantized means that the energy has a certain amount, that electrons can only hold a certain amount of energy. And it says that the atom can change its energy by absorbing or emitting energy. So an electron can gain an amount of energy, and then it can move to a different energy level. So let's see what that means. I don't know why I'm so excited about this today, children. I'm just really all about this Bohr model. Okay, I know that there are more electrons on this sodium atom, but I just want to focus on one electron at a time, okay? So let's say, and these markers really suck, so let me get a new marker. Okay, here's my sodium atom. With my sodium atom, I just want to focus on one electron. And actually, let's say that that electron is really, really close to the nucleus. So if that electron is really close to the nucleus, would that electron have a large attraction or a weak attraction to the nucleus? What do we think? Would the electron have a large attraction to the nucleus or a weak attraction to the nucleus? If you said that it would have a strong attraction, you would be correct. The reason it has a strong attraction is because opposite charges attract one another. So that electron wants to be really close by the nucleus. I am going to have to add energy to move an electron away from the nucleus. Okay, so as I move away from the nucleus, electrons must gain energy. So an electron has to absorb energy to move away from the nucleus. You write that down in your notes. I promise you that will be something on that test. Electrons have to gain energy to move away from the nucleus, and that's because the attraction is much greater when they're closer together. When I move farther away from the nucleus, the attraction is weaker, and the electron does not like that at all. It wants to be very close to that positive charge because positive and negatives attract one another. Okay, so this electron, I need to absorb energy to make it move to the second one, to move to that second energy level. So if I want to show that this electron gained some amount of energy, a certain amount of energy, this electron, I'm going to give it some energy, a certain amount. It's going to move to this second energy level, and I'm going to put a little star there. Do you know why I would do that? I do that because I just gave that electron some extra energy, and it can only hold a certain amount of energy to get it to that second energy level, okay? So because I added some amount of energy to that electron, I gave it a little star just so I know that that electron had to absorb a certain amount of energy. Now, can that electron emit that energy and go back to the first level? Let me ask that question again. Can that electron lose that energy that it just gained and go back to where it came from? It absolutely can. So if I want to do that, I'm just going to do the opposite of what I just did. Let's say this electron loses that amount of energy. It emitted the energy that it absorbed. If it emits, it's going to go back down. So if something gives off energy, it is going to move closer to the nucleus. It's going to move down energy levels. If something emits energy, if an electron emits energy, it will go down energy levels. So that electron just went from the second energy level to the first. So it went down in energy level, and now it's closer to the nucleus, so it is much happier. It doesn't have as much energy as the electrons do in the second. It doesn't have as much energy as the electrons do in the third. So as I move away from that nucleus, I increase the amount of energy, okay? Okay, let's keep going. Okay. Okay.